Dear students, so this lecture, let we learn about the implementation of multiplexers and demultiplexers. So this is experiment number 7 in your syllabus. Let me go to the syllabus here. So your syllabus, study of multiplexer and demultiplexer is an experiment. So that experiment I'll be explaining you how to do, and you can understand the working of mux and demux. In short form, it is called as mux and demux. So what is multiplexer? First you have to understand what is a multiplexer and demultiplexer. Multiplexer means when many input signals are given together, it will be selecting only one input signal depending upon the selection pin, and that will be produced as output. So many input signals are given, only one signal will be selected and that will be transferred. That is the role of a multiplexer. The reverse is the demultiplexer. In demultiplexer, you will have only one input signal and many output pins will be present. You will have selection pins. So from that one input pin will be transferred to the selected output pin, and the selection will be done by means of a demultiplexer. Yes, so let me go here. So this is what a demultiplexer is. You can see here, this is the input pin which is present. You have got a selection pin. This selection pin will select to which output your input should be transferred. If it is 0, 0, it will be transferred to A. If it is 0, 1, it will be transferred to B. If it is 1, 0, it will be transferred to C. And if it is 1, 1, it will be transferred to D. That becomes the role of a demultiplexer. Now let me see the circuit diagram of a multiplexer, and that same circuit diagram is realized in Proteus software for better understanding. You can see here, this is my truth table, and these are my selection pins. You have got 2 selection pins and 4 data lines. So 2 selection pins, this selection pin will take up the values of 0, 0, 0, 1, 1, 0 and 1, 1. You can see here 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so here when 0, 0 is present, the data which is present in the first input pin, that will be transferred to your output. You can see here, when 0, 0 is present, the data which is present in your first input pin, that will be transferred to your output. When 0, 1 is present, the data which is present in your second input pin, that will be transferred to your output. When 1, 0 is present, the data which is present in your third input pin, that will be transferred to your output. And when 1, 1 is present, the data which is present in your fourth input pin, that will be transferred to your output. This input may be 1 or 0, accordingly your output will be changing. The circuit diagram goes like this. So you will have 2 selection pin. The selection pin takes the value of 0, 0, 0, 1, 1, 0 and 1, 1. To take up the alternate values of 0 and 1, a NOT gate is put over here. So when it is 1, the NOT gate output will be 0. When it is 0, the NOT gate output will be 1. And these are the data lines. All the data lines and the selection pin input is fed to your AND gate. So you'll have 4 AND gates. Since 4 inputs are present, you'll have 4 AND gates. The output of the AND gates are OR together by means of an OR gate, and finally the 2 OR gates are again OR together, because in a multiplexer you'll have only one output. So everything will be summed up and it is presented as one output. The output is visualized through an LED. Yes. So let me execute this circuit in Proteus software, and let me see how the circuit is actually going to work. Yes, so the circuit is built up in Proteus software. You can see so many elements are present, 4 AND gates are present, and this is a 3 input AND gate, because 3 input should be fed, 2 from selection pin, 1 from input pin. So this becomes a 3 input AND gate. For every input pin you should have a resistor to be grounded. So this is like a limiting resistor. For every input pin you should have a resistor to be grounded. And all the 4 inputs are ORed together by means of an OR gate. You can use 3 input OR gate, or you can use 2 OR gates, and that 2 are summed up, and finally that is fed to an LED. Yes, and here you can see 4 data inputs are present. So these data inputs have taken the values. The first data input value is taken to be 5. The second data input, the value is taken to be 0. The third data input I have taken the value to be 0, and the fourth data input I have taken the value to be 5. Yes. So now let me see what actually is going to happen here. let me keep the selection pins as 0 0. So when it is 0 0, the first data pin, whatever is present, that should be taken to the output. I am running the simulation. Yes, so you can see that when 0 0 is present, the first data pin is having an output of 5. That is fed to your LED. Now let me take the selection pin as 0 1. When it becomes 0 1, the second data input is fed to the LED. So you can see that it becomes 0 LED. Since it is 0, LED is not able to glow. Now I change my input as 1 0. When it is 1 0, here the data input is 1 again. So what happened here it is 0, so your LED is not going to glow. Now I make it as 1 1. So 1 1 means the fourth data input is 1, so your LED is able to glow. Is that clear? So now what you can understand here is that according to the selection of the selection pins, the data, whichever the data line will be selected, that data will be transferred to my output. Yes, so now the working of your multiplexer is verified with the help of the circuit that is built in Proteus software. Similarly, demultiplexer will be similar to that of your decoder. The same thing you can make it understand, because your decoder and demultiplexer looks to be the same. You can understand that and you can verify your answer by building that in Proteus. That's all for this experiment. Try to verify and understand the experiment. Thank you.